Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0963, pertains to the CVT, Continuously Variable Transmission, Drive Pulley Pressure Control Valve Circuit, high issue in the Honda Fit models from 2015 to 2020. This code indicates an electrical circuit malfunction, specifically in the pressure control valve circuit related to the CVT. It's important to understand that this error is distinct from mechanical problems within the transmission itself. The main component involved here is the CVT drive pulley pressure control solenoid valve, which plays a vital role in maintaining proper hydraulic pressure within the transmission system. Positioned within the transmission assembly, this solenoid valve assists in regulating the pressure that allows for seamless gear transitions. A clear understanding of its function and the surrounding electrical systems is essential for effective troubleshooting. DTC P0963 signifies an electrical problem specifically in the CVT drive pulley pressure control valve circuit. The primary affected component is the CVT drive pulley pressure control solenoid valve, crucial for controlling hydraulic pressure inside the transmission. Located within the transmission assembly, it helps in ensuring smooth gear transitions by managing the fluid pressure applied to the pulleys. When this solenoid valve is not functioning properly, it can lead to issues in shifting and overall vehicle performance. The electrical connections involved include the DRLS, Drive Pulsation Control Wire, leading to the Powertrain Control Module, PCM, which regulates the operation of the solenoid valve. Understanding these components is vital for effective diagnosis and repair of the system. Several possible causes can lead to the activation of DTC P0963. First, a short to power in the wiring between the solenoid valve and the PCM might occur, resulting in increased voltage readings that trigger the DTC. This situation may stem from damaged insulation or exposed wiring. Secondly, a short to ground in the wiring can lead to improper operational signals sent to the solenoid valve, causing malfunction. Finally, a faulty CVT drive pulley pressure control solenoid valve itself can trigger this code if it is defective, thereby impacting the overall functionality of the transmission. Each of these potential causes needs thorough investigation to confirm accurate diagnoses and appropriate repairs. When experiencing DTC P0963, several symptoms may become apparent. The most immediate indicator is the illumination of the check engine light on the dashboard, signifying a problem within the vehicle's systems. Drivers may also notice the transmission slipping, which can contribute to a lack of acceleration and overall poor vehicle performance during driving. These symptoms can significantly affect driving experience and may lead to further complications if not addressed promptly. Additionally, unusual noises from the transmission or hesitation during gear changes may also accompany the DTC. Observing these symptoms is vital for accurate diagnosis and timely intervention. The first step in troubleshooting DTC P0963 involves ensuring the vehicle is in on mode. This is crucial for powering the electrical systems necessary for diagnostics. After activating on mode, use the HDS Honda Diagnostic System to clear the DTC. This step helps in confirming whether the issue is persistent or if it was an intermittent fault. Following that, restart the engine and wait for approximately 1 second. Check the HDS again for any pending or confirmed DTCs. If P0963 reappears, that indicates a confirmed failure, and the next troubleshooting steps must be pursued. However, if it does not reappear, it may suggest a temporary issue. In this case, inspect for poor connections or loose terminals. in Step 2 of troubleshooting DTC P0963. The focus shifts to the CVT drive pulley pressure control solenoid valve itself. Conduct a test to assess whether the solenoid valve operates properly. If it effectively responds as designed, you can likely rule it out as the source of the issue, and should proceed to check for issues in the DRLS line and other wiring components. The DRLS line is critical as it carries signals from the PCM to the solenoid valve. If the valve does not function correctly, additional steps are needed to further isolate the issue. Proper diagnosis at this stage is essential to avoid unnecessary replacements. The third troubleshooting step involves checking for any shorts in the wiring, specifically from the DRLS line to power. First, ensure the vehicle is in off/lock mode. Jump the SCS service check signal line using the HDS to prepare the system for testing. Next, disconnect the PCM connector C and the solenoid wire harness 8P connector. Turn the vehicle back to on mode and take voltage measurements between specific test points. Measuring the voltage will help determine if there is a short to power in the wiring. If voltage is present at the specified point, you will need to repair this short in the DRLS wire. If no voltage is detected, the next troubleshooting step is necessary to assess the line further. The fourth step involves checking for continuity in the DRLS wire while ensuring the vehicle remains in off/lock mode. With the previous connectors still disconnected, test for continuity between specified test points. If continuity exists, it suggests a short to ground in the wiring. In this case, you must repair the short found in the DRLS line to restore proper function. If continuity is not detected, this indicates the wiring is intact. As the next step, update the PCM if it doesn't have the latest software. If potential software revision does not resolve the issue, substituting a known good PCM is necessary. This step is vital for ensuring the accurate operation of the entire transmission control system. In the final troubleshooting step, focus on the CVT drive pulley pressure control solenoid valve's functionality. Begin by removing the valve body assembly to gain access to the solenoid's connectors. With the assembly removed, disconnect the solenoid valve 2P connector and measure the resistance between the designated test points. This measurement is critical. It should fall within the specified range of 4.6 to 6.3 ohms. If the resistance meets these parameters, the solenoid is considered functional, and the next step will be to replace the solenoid wire harness for addressing the DTC. Conversely, if the resistance does not fall within the specified range, it indicates a faulty solenoid valve. In this case, replacing the valve body assembly will rectify the issue. Once the necessary repairs concerning DTC P0963 have been made, conducting a final verification is essential to ensure the system operates properly. Begin by running the vehicle to confirm that it operates as intended. Monitor the vehicle's performance closely, checking for any signs of the check engine light illuminating again, which would indicate that the issue may still persist. Utilize the HDS to scan for any DTCs post-repair. A clean scan without DTC P0963 confirms successful repairs. Finally, take the vehicle for a brief test drive under normal driving conditions, checking for any operational issues such as transmission slippage or unusual sounds. If everything checks out, the repair can be deemed complete. Preventive maintenance plays a pivotal role in avoiding issues like DTC P0963 in the future. Regularly inspecting the electrical systems for any potential wear or damage is essential. This includes checking connections associated with the solenoid and PCM. Additionally, routine changes of the CVT fluid help ensure that the transmission remains free of contaminants. which can cause wear and malfunction. Scheduling inspections of wiring, especially in high-stress areas, ensures that shorts or degradation do not develop unnoticed. Keeping these preventative measures in mind can help maintain the longevity of the transmission system and its components, ultimately leading to better overall vehicle performance. In conclusion, addressing DTC P0963 effectively requires a clear understanding of the potential causes, symptoms, and a systematic approach to troubleshooting. From identifying faulty wiring, verifying solenoid function, to rectifying any issues found, each step plays a critical role in resolving the DTC. Preventive measures, such as regular inspections and maintenance, can significantly reduce the likelihood of recurrence. Being aware of the electrical systems that interact with the CVT is essential for any technician or vehicle owner. By following the outlined steps and implementing preventive maintenance, one can ensure that the vehicle continues to operate reliably without encountering the same problems. Please like and subscribe to the channel. See you next time.